be solving Euclid's Proposition 12, and his enunciation for Proposition 12 says that to a given infinite straight line from a given point which is not on the straight line, to draw a perpendicular straight line to that. And so we're going to be proving that we can construct a line from our given point, which is C, down to our given line, which is AB, that is perpendicular to line AB. So our first step would be to take point D at random. We'll just place point D right here. After that, we would construct our circle of E, F, G, and we can do that because of postulate 3, which says that if with a given center and a given distance, you can construct a circle with those. And so our given center is center C, and our given distance is the distance of CD. And so after that, we would take the point of H, which is going to bisect line GE. And we can do this because of Proposition 10, which says that with a given finite straight line, you can bisect that line. So we'll take the center, this point H, and we'll show that GH is equal to HE because it has been bisected. After that, we would construct the lines of GC, CH, and CE because of postulate 1, which says that with two given points, you can connect those 2 points to create a line. After that, we would show that line CE is equal to line CG, and that is because of definition 15, which says that any radius of a triangle will be equal to each other, or of a given circle will be equal to each other. And so after that, we could be able to show that the triangle of GCH will be equal to the triangle of CHE, thanks to Euclid's Proposition 8, which says that given a side, and a side all in common with another triangle, those two triangles and every angle inside of it will be equal to each other. And so we know that these two sides are equal because they are both radiuses, and these two sides are equal because we've bisected them, and they share this common line, that they have a side, and a side all in common. And so we would show that this angle right here, which we'll name X, and this angle right here, which we will name Y, will both be equal to right angles because of definition 10, which says that if a straight line is falling on top of another straight line, those two angles will be equal to each other, and they will equal right angles. And so by doing that, we can prove that line CH is going to be perpendicular to line AB, because the definition of a perpendicular line, which Euclid gives us in definition 10, is going to have a straight line falling on top of another straight line, which makes those two angles equal to right angles. And so that is how Euclid solves Proposition 12.